Hey, Accelerated Algebra. This is all about section 10.2, which is simplifying radical expressions. It's in your textbook, so you can look at that. Be sure you're taking notes. Here are a couple of problems that showed up on Khan Academy yesterday, or maybe similar ones for you. They had you assuming that all the variables are positive. We're going to talk about that detail later, but for now we'll assume that these variables are positive. So remember, the idea is to take out perfect squares. So for this first one, we can just go ahead and do 6 times 2, and that gives me 12, and y to the 4th times y squared. Now we've got to simplify from there, remember taking out the perfect squares. So this should simplify to be, so this all simplifies to be 120 y cubed root 3. Okay, let's just do one other one like it. Maybe pause, give this one a try if you didn't do it yesterday, and then check your answer. Okay, for this next one, you might want to use some little shortcuts just so that you don't have to do 14 times 21. I can still do 5 times 4 and get 20. And then let me just bring these z's all together. I'm going to have z to the 5th, and then I'm going to have under the square root the 14 times the 21. Let's simplify this part first. We're going to take out the z to the 4th and take the square root of that. So we're going to have 20z squared, square root of z. And then let's think about this 14 times 21, so we don't have to do a bunch of calculations in our head. 14 is just 7 times 2, and 21 is 7 times 3. So you can kind of see we're going to be able to take a 7 out of the square root and leave the 2 times 3 in the inside. So here this is going to give me 20z squared, and then I'm going to have that times 7. Left under the square root, I'm going to have the z and the 6. So when I go to simplify this, I'm going to get 140z squared, square root of 6z. So that's all the stuff from Khan Academy yesterday, and you can go back and look at those videos again if you kind of need a refresher. Okay, so you might have this question of like, how do I know when it's even simplified? So the first rule is that here under the radicand, you can't have any perfect squares, except for one, of course. And then the radicand can't have any fractions, so that 7 couldn't be, for instance, a 1/2. We'd have to work on that. And no radicals in the denominator. That's kind of an old rule, but people still go by that convention. Okay, so for now, we're going to assume the variables are positive. Then we'll talk a little bit about if that isn't true. So here, let me think of the biggest perfect square I can think of that divides 32. That's going to be 16. So I'm going to write this as 4, and then the square root of 16y squared. What's left under the square root is just a 2y. So this is just 4 times 4y root 2y. So that's going to be 16y root 2y. All right, for this next one, we cannot have a square root in the denominator. We get this nifty property of square roots, that if we have the square root of a over b in a fraction like this, you can actually break that up. And so I'm just going to do that here. For this last one, we cannot have a radical in the denominator, so we're going to do this thing called rationalize the denominator. So the trick here is just to multiply by the right fancy form of 1, which for me is root 2 over 2, the same as 1. So now in the numerator I've got 3 root 2, and in the denominator I've got the square root of 2 times the square root of 2, which of course is just 2. So now I've got 3 root 2 over 2. And that might not seem more simple than this, but there's a reason why people used to do it that way, and you need to at least know that this is the same as the answer that we got here, so that you're able to know, like, if you have the same answer, if you have the right answer, so on. Okay, what if we can't assume that the variables are positive? How does that change things? It's a little bit of a nitpicky detail. So suppose here that we had a negative value for y. So suppose that y was something like y equals -1 even, right? Then if we go to simplify this and we assume that y was -1, this would be a -1 right here. But we wouldn't actually, in the whole process, we wouldn't actually end up with this being negative. Not if you square it. Once we square it here, it would be positive, and take the square root, we get a positive here. So there's this nitpicky thing that you would have to do. You'd have to write this as 4 times 4 times the absolute value of y, root 2y, to really make this accurate. So you'd write your answer as 16 times the square root of, the absolute value of y times the square root of 2y. And that is kind of a picky thing, but it is something that the book does, and I just wanted you to be aware of it. Okay, a little bit more practice rationalizing the denominator. So here, think of what magical version of 1 you want to multiply by. Here, we have to be kind of fancy. So remember our old friend difference of squares. Conjugates are something we're going to talk about right now, and they work a lot like that. So here's our difference of squares pattern. Now, we've got this nifty conjugate thing. If we do 3 plus root 2 times 3 minus root 2, and notice that's just like difference of squares, right? Or that's just like the first part of that pattern. Then we're going to get 3 squared minus root 2 squared. Well, 3 squared is 9, and root 2 squared is 2. So now I've got something here, and that's rational. That's why this is called rationalizing the denominator, because you end up with something, a rational number, not an irrational number. Here we're going to multiply by this fancy conjugate, 3 minus root 2. Watch what happens when we do that. And now I have a rationalized denominator, no radical in the denominator. What are you going to multiply by here? Okay, hopefully you thought of 3 plus root 5 on the top and the bottom. Notice that all these things are divisible by 4, so that can be simplified one more step. So this little note here is just saying what's the point? The trick is to help us to get rid of the radicals in the denominator. And then check your solutions on the slides.